Hi guys, welcome to another episode of MrLopezClasses.com. This is our chapter 13. This chapter is diesel fuel injection pumps. Yes, we are going to study today the different type of fuel injection pumps, mechanical fuel injection pumps, electronic fuel injection pumps, how the pumps are configured, and how the pump control the RPMs, control the amount of fuel, control the amount of air. Is the vital component in a diesel engine. And yes, we are going to analyze at the end of this chapter the troubleshoot, what happened when the fuel injection pump and the injectors are working properly, what happened when the amount of fuel entering in the combustion chamber is not enough according with the amount of air, the stoichiometric ratio is affected, what is the symptom, what is the consequence. Yes, this is the last part of this chapter. I hope you enjoy this chapter. Okay, we are going to start with the first slide. Is related with the characteristics of the fuel injection pump. The purpose of the fuel injection pump is deliver the exact amount of fuel under high pressure exactly in the time where the piston is at the end of the compression stroke at top the center. There are many different features on an injection pump that provide the characteristics of the diesel engine. One of those characteristics is the anaeroid function to avoid black smoke, especially at low speeds in turbocharger engine. This is very important. Function is an special sensor valve that control according with the atmospheric pressure, according with the altitude, internally regulate the amount of air and the amount of fuel entering in the combustion chamber. In my opinion, after the computer, after the ECM, the fuel injection pump is the brain of the system. Of course, in diesel engines with mechanical fuel injection system, the brain of the system is the fuel injection pump. Right now we are going to check the division of the fuel injection pumps, the parts, and what is the function of each part. It's a wonderful invention. This is one of the inventions of the previous century with the automatic transmission. Both of them, in my opinion, are perfect robots. Other function is the governor. The governor controls the RPMs. Very important, the governor. And also, according with the load of the engine, according with the load of the main engine, the fuel injection pump controls the torque. Yes. Other important function of this type of pumps. The injection pump is the heart of the engine, of course. It is responsible for deliver the fuel to the engine and control the speed with the governor. The injection pump does the job for both the ignition system and the throttle body. Yes, this is exactly this picture. The fuel injection pump, the diesel fuel injection pump, have the same function that the ignition system plus the throttle body in gasoline engines. This is gas and this is diesel. Yes, the fuel injection pump have the same function of both of them, the ignition system and the throttle body. This is the air. And this is the spark. It's the brain of the system. Yeah, doesn't matter if the fuel injection pump is mechanical or electronic, performs the same function. Control the ignition and air together in one element. The name of that element is the fuel injection pump. Yes, my friends, because that unit, because this unit control the ignition and the amount of air, this element, the injection pump, control the timing. You remember in gasoline engines how you adjust, how you advance or retard the timing? Yes, when you move it, the distributor back or forward, you remember? Exactly. In diesel engines, the governor internally control the advance or retard of the timing. It's an intelligent element. It's an intelligent component. The timing is adjusted in response to the engine RPMs. At higher RPMs, the fuel pressure coming from the pump is higher. The pressure change effects are controlled by a spring and a plonger that I am going to explain right now in a long video, specially detailed with small demonstrations where are controlled the RPMs and where are controlled the amount of air entering in the combustion chamber. Okay, and also this the fuel injection pump control the cold start, especially in the morning at low temperatures, advancing or retarding the timing. It's a wonderful equipment. It's an intelligent element. It's the heart of the system. And those are other functions of the fuel injection pump. The governor is a mechanical element that limit the maximum wide open throttle speed. Normally in marine engines is around 2200 RPMs, 2500 RPMs is the typical maximum RPMs in an inboard diesel engines. And also the fuel injection pump control the procedure to stop the engine because with the solenoid control valve control that the fuel enter or not enter at the pump, and of course immediately the engine stop. This is the stop solenoid. Is a magnet valve or solenoid that control the input of the fuel in the fuel injection pump. Another important element is the aneroid. Is an air inlet pressure sensor. Is used to check the maximum amount of fuel delivered on the injection pump, especially for turbo engines. A lot of functions for the fuel injection pump. This is the schematic that I prepared for you in order to explain easily the function of the fuel injection pump. Yes, my friend, in this point you have the fuel tank. In this area you have the fuel tank, and after that you have a valve, the primary filters or water separator filters. In between both filters you have the pressure gauge, you remember, in order to identify the conditions of the elements inside of the primary filters. After that you have the secondary filter. And after that, after the secondary filter, the fuel pass for the transfer pump. Normally the transfer pump will be located here or here, doesn't matter. The fuel enter at the input of the fuel injection pump. This is the input of the fuel injection pump, and from the output of the fuel injection pump you have the injector. From this point to the injector is considered the high pressure side of the system, and the low pressure side is considered from this point into the fuel tank. This is the schematic. Of course, this pump, the fluid enter here only if the solenoid is open. The solenoid open and close for those cables, and those cables are connected with the ignition switch, exactly the same like the transfer pump. Both of them, transfer pump and the solenoid at the input of the fuel injection pump, both of them are controlled by the ignition switch. When you activate the first position on the ignition switch, you activate both of them. You activate the fuel transfer pump, low pressure pump, and the solenoid of the fuel injection pump. Both of them. Right now we are going to talk about each of those elements in the next coming video. Okay, this is the video, and I want to share with you everything. Rotary mechanical fuel injection pump. Okay, from the transfer pump, the fuel enter in the rotary fuel injection pump. Okay, and this is the solenoid is controlled from the ignition switch. Okay, the fuel enter, low pressure, and this is the output, high pressure. Input, low pressure, output, high pressure. Input and output. 6 output in this particular case. Okay, this is another example of the rotary. The gear of that pump engage, the marks engage, they are aligned with the marks of the camshaft and with the marks of the crankshaft. Don't forget that. This is very, very, very important. This is the properly position at 0 position. Remember, in other example, in other projects that we did on the laboratory, the marks depend on the manufacturer. Each manufacturer have a different position for the marks. For that reason, always follow the manufacturer recommendation. This is the most important part, right? And this is the handle for the RPMs. The handle of the RPMs is directly connected with the station, with the control at the pilot hand. In some cases, the connection is mechanical, like this, with a cable, or in some cases, the connection is electronic. We are going to talk about those controls in our class of auxiliary systems. Those are the control, but both of them have the same function. Control the handle on the fuel injection pump. On that handle, in this handle, you administrate the RPMs. You accelerate or decelerate. Yeah, that's the control. Yeah, that's the connection. Okay, inline mechanical fuel injection pump. The previous one was the rotary mechanical fuel injection pump. Both of them, the previous one and this one, are used in low pressure system. You remember, low pressure systems are in between 75 psi and around 3000 psi. Okay, this is the inline, or the very, very common mechanical fuel injection pump. We are going to disassemble the pump, and we are going to check internally how the fuel enter, how the RPMs are controlled, and how the pumps compress the fuel from 20 psi into 3000 or more psi in the output. Okay, this is the inline, is for low pressure system. Okay, the fuel injection pump is divided in 2 sections: the block of the fuel injection pump and the governor in the second part. This is the block. This small block is like a replica of the big engine. This is a perfect replica of the big one. Internally, we are going to study right now, we have a camshaft here, and we have a cylinders with pistons. The name of those elements, cylinder with piston, is the plunger. Okay, you have a 1, 2, 3, 4, 5, 6 plungers in this particular small engine, because the big engine is 6 cylinders. And this small engine, this small block, work in parallel with the big block. What is the meaning of that? The plunger number 1 work at the same speed, the same angle with the piston number 1 of the big engine. Because the position of the lobes in the camshaft, the angles of the lobes are exactly the same like the angles of the lobes in the big camshaft. Right now we are going to check that situation. Okay, this is the block, the mini block of the fuel injection pump. Is a replica of the big block of the engine, and this area is the governor. The governor control the RPMs, control the load. That's the intelligent part of the fuel injection pump, is the governor. Okay, now we are going to check what happened in this small mini block. Okay, and this is the governor. Okay, the mini block. Okay, normally here in this position is located the priming pump, manually, mechanical priming pump. That priming pump is moved by the small camshaft of the fuel injection pump. This one, exactly, that pump, exactly. This is the mechanism that is compressed for the camshaft of this small mini engine. Yeah, and it's bolted over there, and you can prime with your hand. This is the handle. Okay, the fuel enter here, and after that enter in the fuel injection pump. This is the input of the fuel injection pump. Internally, you have in this mini engine in this mini engine, you have a small manifold internally for intake, and in the other side, in the back, you have other manifold inside of the mini block for the return. Okay, look at this. The fuel enter here, pass over there, and enter here. That's the input, and the fuel enter in each plunger, in each small cylinder. And in the other side, the fuel return, and this is the return and goes into the fuel tank. Okay, that the input enter in each small cylinder, in each plunger, and in the other side the return over there and return into the fuel tank. It's clear? We have exactly the same like in the big engine. One intake manifold or supply manifold or discharge manifold, and one return manifold. The return manifold is connected with the return of the injectors. Do you remember? The return of the injectors is connected with the return of the fuel injection pump, and both of them goes into the fuel tank. Because remember, only around 20% of the fuel is used to produce power and 80% return. Okay, my friends? This is the return, and this is the handle. That's the handle for the RPMs. This is the handle that is connected with the console, with the control on the console. Yeah, in this point, the cable is connected. All right. This is the handle for the RPM, and you have two bolts. One bolt for idle, and other bolt to adjust the wide open throttle. Normally, those bolts have a cable over there, safety wire, in order to avoid that the people modify the wide open throttle and the idle. Yeah, with those safety wires, especially in generators, because remember that the generator runs at constant RPM. Can you refresh me? What is the RPMs for European generators? 1500 RPMs. And the RPMs for American generators? 1800 RPMs. In those cases, in those generators, you need to fix the bolt for idle and the bolt for wide open throttle in order to keep the acceleration constant. Okay, this is the bolt for idle, and this is the bolt for wide open throttle. All right, you can adjust both bolts, and this is the solenoid to stop the engine. Look at the solenoid. Open, close, open, close. When the engine is off, the solenoid is extended and the fuel no enter. When the engine is running, the solenoid is compressed. Simple. This is the solenoid used to stop the engine. Yeah, in a diesel engine, when you press the button stop, you activate that solenoid and the engine stops. You cut the fuel. There are two ways to stop a diesel engine. One way is when you cut the air, no more air, and the engine stops. Or when you cut the fuel and the engine stops. Right? In the majority of the diesel engines, they stop because the solenoid at the input of the fuel injection pump cut the input of fuel on the pump. All right? This is the solenoid. All right? To activate the pump, perfect. To start and stop. Okay, the next pump is the electronic fuel injection pump, common rail. For a common rail system, we are going to talk later. It's not complicated. It's a common manifold for the input. This is for low pressure. And I am going to explain another one for high pressure. Okay, this one in particular is electronic for common. Okay, this is the electrical pump or electronic pump. This pump receives the power here and here from the computer. The computer, the ECM of that engine, send the signal to activate that pump. And that pump receives low pressure here and send in the output high pressure. It's high pressure because it's around 3000 psi or a little higher. But in terms of fuel injection system, this is considered low pressure. All right, this is the fuel injection pump, electronic fuel injection pump, that's the input, and This is the output, correct? That's the signal coming from the computer. This is the output, and the output enter in the filter, in the secondary filter. Okay, my friends? Because this is high pressure, it's 3000 psi or higher. This filter have a return on top into the tank. When the engine is in idle, a lot of fuel return into the tank. When the engine is at a wide open throttle, high RPMs, less amount of fuel return into the tank. And additionally, in this bracket, you have the bleeder. This is the valve to bleed the system, to eliminate the bubbles, especially when you replace this filter. Can you refresh to me what is the procedure what is the tip when you replace that secondary filter? Yes, you added in the bottom a little amount of motor oil, and on top you introduce the fuel, and you bolted the filter with your hand. That's it. Okay, my friend. This is the bleeder. Correct. That's the fuel. That's the bleeder. You bleed the system. Yes, you bleed the amount of air. Okay, and the excess of fuel, return into the tank. Yeah, especially in idle. Okay, the fuel is going out and enter in this compartment. This compartment is the fuel cooler. Remember, the majority of the diesel engines, they have a fuel cooler in order to reduce the temperature of the fuel a little and avoid that the fuel enter in the combustion chamber with high temperature in order to avoid vapor lock. Okay, this is the fuel cooler. That's the input of the fuel cooler, and right now the fuel goes over there into the serpentine and continue here, and enter in the manifold for the common rail. The manifold in that particular engine is casting internally in the head. The head internally have two cavities. One cavity is for supply and other cavity for return. Okay, in this particular case, the fuel enter here and enter in the head, in the intake manifold. The manifold that receive the fuel, the intake manifold or supply manifold. Okay, and from the manifold, the fuel enter in each injector. Those are the injectors. In this particular engine, the injectors are mechanical injectors. Mechanical injectors. What is the meaning of that? Those injectors open and close for a mechanical system. The mechanical system is this. Is a rocker arm. The rocker arm is activated for the camshaft of the engine. The camshaft of the engine have lobes for the valves, intake and exhaust, and other lobes in the middle for the rocker arm of the injector. When the valve start, when the valve finish, when the piston finish, the compression struck, the injector open and spray the fuel and produce the explosion. Yes, this rocker arm is connected in one side with the camshaft, and in the other side open and close the injector. Let me show to you this. It's a nice design. This is the rocker arm. In this end, you have the loads for the fuel injector, and you have one loads for exhaust valve, other loads for intake valves. Yeah, valves in each side, intake and exhaust, and this is the rocker arm for the fuel injector, valves and injector. Yeah, then right now I am going to start the engine to show to you how that engines operate. Yeah, that's the lubrication. Exactly, the rocker arm in the middle. Exactly, right now the engine is running. The engine is running. The valves here, and the rocker arm for the fuel injector over there. In the other end of the rocker arm, the injector is compressed, and the injector sprays the fuel each time that the piston finishes the compression stroke. Alright, the other system is a mechanical fuel injection pump for common rail also, but this is high pressure. You remember high pressures are considered in between 10,000 psi and more than 17,000 psi. It's a high pressure. And this is the mechanic. This is a mechanical fuel injection pump. What is the meaning of that? The pump, the gear of that pump is connected with the gear of the cam and the gear of the crank. But in this particular case, you don't need to install that pump on time, because that pump is constantly producing power, and the power, the fluid enter with high pressure in the common rail, and the common rail is constantly pressurized. But the fuel enter in each injector only if the injector is open. The injector receives the signal from the computer, like this. This is the situation. Okay, this is the pump. This is a mechanical pump. Mechanical pump connected the gear here with the gear of the crank and the gear of the crank, but this is for high pressure. The input enter here, and the fuel goes over there and goes over there and enter in this pressure regulator. This is the pressure regulator. That element control the pressure before the fuel enter in the fuel common rail. Okay, and this is the sensor, the sensor for high pressure, the high pressure sensor. Okay, and the fuel continue over there, and the fuel continue exactly. This is the sensor, and the fuel enter in the common rail. Perfect. This is the common rail. The common rail, and the common rail send the fuel to each injector. Send the fuel to each injector, and each injector receive the signal from the computer. Receive the signal from the computer. Correct. 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 Remember, in this engine, the injector have a input in one compartment of the body of the injectors and return in the bottom. You remember in the previous episode? Correct. Okay, those connectors are coming from the computer. Those are the clips. The connectors enter over there. This is the adapter. Those are the clips, and that's the clip in order to avoid that the cables loose. All right. Those are the most common type of fuel injection pumps. And now we are going to start to disassemble the pumps. We are going to start to analyze the pumps, and we are going to verify how is the pump internally.